In 1974, the United States government deployed one of the most elaborate deceptions in Cold War history. Howard Hughes, one of the richest and most eccentric men in the world, publicly announced that he had built the world's first commercial deep-sea mining vessel. He claimed his ship, the Glomar Explorer, would extract polymetallic nodules from the floor of the Pacific Ocean. The financial press covered it. The technology press analyzed it. Competing governments tracked it with genuine concern. None of it was true. The Glomar Explorer was a CIA vessel. It had been constructed at a cost of several $100 million to recover a sunken Soviet submarine, the K-129, which had gone down in the North Pacific in 1968, carrying nuclear warheads and cryptographic equipment. The mining story was cover. The technical specifications, the press releases, the investor briefings, all of it was designed to explain why an enormous ship was operating alone in the middle of the Pacific Ocean, lowering equipment to the seafloor. The CIA never mined anything. The cover story worked well enough to partially recover the submarine, and well enough to be believed. But here is what no one was planning for. The cover story was so technically convincing, so commercially plausible, that it triggered an international legal crisis. Developing nations and the Soviet bloc became alarmed. If the United States could mine the deep Pacific floor commercially, they argued, then the mineral wealth sitting in international waters was about to be captured by a handful of wealthy countries with the technology to reach it. The response was unclose. A governance institution was built specifically to prevent that race. The CIA never mined the Pacific floor, but the lie it told created the international law that is now failing to govern the real race. Because the mining is real now, and the rules are not ready. If the question of how hidden physical structures become the real engines of power is what you want to keep understanding, you are in the right place. Stay with it. Most people who think about the energy transition think about batteries, and most people who think about batteries think about the metals inside them. Cobalt from the Democratic Republic of Congo, lithium from the salt flats of Chile, nickel from mines in Indonesia and the Philippines. These are the materials that store energy, that make electric vehicles move, that underwrite the infrastructure of a post-carbon economy. This is the supply chain most analysts discuss. This is the map most people use. The problem with that map is that it focuses on the wrong geography. In the Clarion-Clipperton Zone, a stretch of the Pacific floor running roughly from Hawaii toward Mexico, at depths between 4,000 and 6,000 meters, there is more cobalt, nickel, manganese, and copper sitting on the seafloor than in all known land deposits on Earth combined. Not locked in hard rock, not buried in ore veins, sitting on the sediment in nodules, irregular, fist-sized rocks, black-brown and dense, scattered across the floor in concentrations dense enough to cover it like cobblestones on a very dark street. These nodules are not geological accident. They are the product of an extremely slow chemistry. Metal ions dissolved in seawater, precipitated over millions of years around a seed. A shark tooth, a fragment of ancient shell, a splinter of volcanic rock, a centimeter of nodule represents something in the range of several million years of formation. They are, by any practical human timescale, non-renewable. You cannot farm them, you cannot synthesize them, you cannot replace a nodule field once it is gone. The Clarion-Clipperton Zone alone covers approximately 5.5 million square kilometers, an area larger than the continental United States. Current estimates suggest it contains around 340 million metric tons of nickel, 44 million metric tons of cobalt, and 7.4 billion metric tons of manganese. The cobalt figure is more than 4 times the total of all currently known land-based reserves combined. HMS Challenger first dredged nodules from the Pacific in 1873 during the first systematic global ocean survey. The scientists on board recognized immediately that they had found something of enormous value. They also understood with some precision that they had no way to reach it. They cataloged it and moved on. A century and a half later, the technology is approaching. The question is no longer whether those nodules can be extracted. The question is who will govern the extraction, and whether the governance architecture that was supposed to answer that question is equal to the task. It is not. The International Seabed Authority was created to solve exactly the problem that is now occurring. Established under UNCLOS when the treaty entered into force in 1994, the ISA is headquartered in Kingston, Jamaica. It has 168 member states. Its founding mandate is clear: to manage the mineral resources of the international seabed, the areas beyond any national jurisdiction, for the benefit of all humanity, not for the nations with the best technology, not for the companies with the largest investment, for humanity collectively, with revenue shared, with developing nations protected, and with rules in place before the race for resources began. The ISA began issuing exploration contracts in the early 2000s, licenses to survey nodule deposits, assess their extent, study the environmental baseline. By 2023, 31 such contracts had been granted. The theory was straightforward: exploration first, then a regulatory framework, a mining code that would govern actual extraction. What environmental standards would apply, what royalties would be paid, how benefits would be distributed. The mining code has not been written. In June 2021, the government of Nauru made a legal move that few people noticed. It invoked a provision buried in the UNCLOS framework, sometimes called the 2-year rule, under which a sponsoring state can formally request that the ISA finalize its regulatory work within 2 years. The ISA must then either complete the code or allow mining applications to proceed under whatever interim rules exist. Nauru invoked this provision on behalf of a mining company with exploration rights in the Clarion-Clipperton Zone. The 2-year clock ran to its end in July 2023. The ISA was deadlocked. Delegates from 168 countries were still debating environmental baselines, royalty structures, benefit-sharing formulas, and monitoring standards. No mining code was finalized. The deadline passed, and the legal consequence of that failure is that commercial extraction applications can now technically be submitted and processed under a framework that was never completed. The institution built specifically to prevent the seabed scramble has missed the moment when it mattered most. Open questions of this kind are not answered by delay. They are answered by whoever moves fastest while everyone else is still negotiating. Not every actor in this race arrived equally prepared. China holds more exploration contracts in the ISA system than any other single nation, covering areas in the Clarion-Clipperton Zone, the Indian Ocean, and the Western Pacific. Those contracts are not merely administrative filings. They represent years of systematic survey data, knowledge of nodule density, seafloor topography, sediment conditions, and environmental baseline measurements that took decades to accumulate and that has no substitute except time. A nation arriving at the starting line of commercial extraction without that data is not starting late, it is starting blind. China's deep-sea mining technology program is the most advanced in the world by most available metrics. The China Ocean Mineral Resources Research and Development Association has been conducting deep-sea survey operations since 1991. China has deployed crewed research submersibles capable of reaching depths exceeding 10,000 meters, now the deepest point on Earth. It has tested prototype nodule collection vehicles at operational depth. It has invested in the riser technology, the robotic systems, and the processing infrastructure required for commercial-scale extraction to a degree that no Western program has matched. This compounds in a specific way. The bottleneck in the nodule race is not knowledge of where the reserves are. Multiple actors have mapping data. The bottleneck is extraction capability. Who can actually reach the floor, collect nodules at scale, bring them to the surface, and process them at costs that make commercial operation viable. That bottleneck is technological, and the technology gap at this moment is real and wide. There is one further structural asymmetry worth naming directly. The United States never ratified UNCLOS. It never joined the treaty, which means American companies cannot hold ISA exploration contracts in their own right, and the U.S. government has no formal voting seat in the institution governing the seabed resource that the energy transition depends on. The country that spent hundreds of millions of dollars building the Glomar Explorer to fake Pacific floor mining in 1974 is not a party to the legal system that fake mining produced. It has no formal mechanism to shape the rules for the real race. The irony is not incidental. It is structural, and it matters. There is a pattern here worth seeing clearly, because it is not specific to the Pacific floor. Every major civilizational energy transition in modern history has followed the same underlying logic. The transition to coal was a story about who controlled coal fields and the infrastructure to move them. Canals, rails, ports. The transition to oil was a story about who sat atop the geological formations where oil accumulated, who could reach those formations and process what came out of them, and who controlled the routes through which processed hydrocarbons moved to market. In both cases, the leverage in the transition was not primarily political or technological in the first instance. It was physical. It was material. It was geological. The transition to clean energy is being narrated as something fundamentally different, as an escape from the geopolitics of extraction, as a departure from resource dependency, as a future in which the energy system is democratic by design, powered by sun and wind that fall on every country equally. That narrative contains a real truth. Sunlight and wind are distributed broadly, but the materials required to store that energy, to move it efficiently, and to build the infrastructure that captures it, those materials are not distributed equally. They accumulate in specific geological formations under specific conditions in specific places, and the ocean floor is one of those places. Perhaps the most significant one that civilization has not yet seriously reckoned with. The energy transition is not leaving resource geopolitics behind. It is migrating resource geopolitics to a new location. The location is darker, deeper, and less visible than any previous resource battleground in history. It has no obvious political geography, no flag planted, no coastline drawn, no border that a news camera can stand at. But the logic operating at 4,000 meters depth is identical to the logic that operated in the oil fields of the Persian Gulf and the coal seams of the Ruhr Valley. Whoever positions themselves in the new physical geography of power, before the rules are written, before the governance catches up, before the public conversation reaches that depth, holds leverage that the transition cannot escape. If that pattern, the way the Earth's physical logic always sets the terms of power before anyone is watching, is the kind of argument you want to keep following, this channel builds it. Subscribe and stay. In 1873, scientists aboard HMS Challenger dredged fist-sized rocks from the floor of the Pacific Ocean and recognized with real astonishment that they had found something of enormous value that no one would be able to reach for a very long time. They were right about the value. They were right about the wait. The wait is almost over. The rules that were supposed to govern what comes next are not ready. The institution built to prevent the scramble has missed its moment. The countries with the most data, the most exploration contracts, and the most advanced extraction technology are operating inside the vacuum that the unfinished rules left open. and the global conversation about the energy transition is still largely focused on the wrong geography. On land, in countries whose names appear in trade arguments and policy reports, when the real terms are being set somewhere that has no flag and generates no headlines. Earth is not background. Earth is the machine. The floor of the energy war is already being decided in the deepest place on Earth, in the absence of rules, by actors who moved before anyone was watching. The question is not whether this race will be won. The question is whether anyone else noticed it had started.